Hello, Assalamualaikum. My name is Nurul Ain binti Rumaizi, ID 23396. Okay, this is my slide. My slide is about digital to analog modulation. So, the point, I got 4 points for this presentation, which is amplitude shift keying, frequency shift keying, phase shift keying, and quadrature amplitude modulation. So, this slide is about amplitude shift keying, which is ASK. ASK is a form of amplitude modulation that represents digital data as variations in the amplitude of a carrier wave. So, ASK is in an ASK system, the binary symbol 1 is represented by transmitting a fixed amplitude carrier wave and fixed frequency for a bit duration of t seconds. If the signal value is 1, then the carrier signal will be transmitted. Otherwise, a signal value of 0 will be transmitted. So, ASK uses a finite number of amplitudes, each assigned a unique pattern of binary digits. So, ASK can be divided into 3 blocks, which is transmitter, channel, receiver. So, you can see from the picture there is 3 blocks of ASK. And this is a graph of binary amplitude shift keying, which when there's the binary number is 1, it gives a signal of one signal element, and so on about and it is have 5 bit rate 10110. And so this is the implementation of binary amplitude shift keying, ASK. Okay, there is 3 kind of graph. The middle one is the carrier signal, and the below one is the modulated signal. Basically, I got this from lecture note. Alright, for the second point, frequency shift keying, FSK. FSK is a frequency of modulation scheme in which digital information is transmitted through discrete frequency changes of a carrier signal. Binary frequency shift keying in a simplest BFSK is the simplest of frequency shift keying, FSK. Binary frequency shift keying uses a pair of discrete frequencies to transmit binary 0 and 1 information. 1 means mark frequency, but while 0 means space frequency. So this is the graph for the binary frequency shift keying. It is a bit similar to the amplitude shift keying. Okay, so for the phase shift keying, PSK, it is a digital modulation scheme that conveys data by modulating the phase of a reference signal, the carrier wave. The modulation occurs by varying the sine and cosine inputs at a precise time. Phase is changed to represent the data signal. Changes in phase of a signal broadcast waveform can be considered the significant items. Since this scheme depends on the difference between successive phases, so it is termed differential phase shift keying, DPSK. DPSK can be significantly simpler to implement than ordinary PSK, since there is no need for the demodulator to have a copy of the reference signal to determine the exact phase of the received signal. It is a non-coherent scheme. So, this is the binary phase shift keying, and below it is the quadrature phase keying and its implementation. Right, for the last one is the quadrature amplitude modulation, QAM. It is basically a combination of ASK and PSK, which is amplitude shift keying and phase shift keying. And it conveys two analog message signals or two digital bit streams by modulating the amplitudes of two carrier waves. Using the amplitude shift keying ASK, digital modulation scheme or amplitude modulation AM analog modulation scheme. The two carrier waves of the same frequency, usually sinusoid, are out of phases with each other by 90 degrees and are thus called quadrature carriers or quadrature components. So QAM is used extensively as a modulation scheme for digital telecommunication systems. So this is a three constellation diagram. The first one is from the ASK. Second one is binary phase shift keying, and for the third one is quadrature phase shift keying. Alright, that's all from me for my presentation. Enjoy. Thank you.